All right, here's the Unit 4 Assessment Study Guide. Okay, so number 1 is seen here. All businesses that strive to look at data, movie theaters are yet another example of a business who looks at data to see how they can improve. The table below looks at data at those who purchased the movie ticket only compared to those who purchased the movie ticket as well as purchased food. In 1 week, 1,275 women and 1,090 men purchased a movie ticket. 2,100 women and 2,480 men purchased a movie ticket as well as purchased food. Complete the following two-way frequency table. So as you see down here, I have put these data points in where they belong. So men, movie ticket only, right there, etc. Okay. The item that I had to do was I had to then total what these were, as well as here, as well as this total. Okay. So I had to do that math. Then B says, how many people went to the movies this week? Okay, that answer is right there, 6,945. What percentage of people who went to the movies were men who only bought a movie ticket? So again, I'm looking at this number right here, but it's out of this number here. So I do the division problem, which equaled this, and then of course I multiply it times 100 to give me this percentage. And then D said, are men or women more likely to go to the movies? Explain your reasoning. Well, I went with men because men bought more tickets than women, and you can see that over here. This number is bigger than that number, and I could have also done the percentage. All right, question number 2, the number of homework assignments turned in and how well an individual does in class. So the variables are the number of homework assignments turned in and how well an individual does in class. And then the other two, I would go with it is likely that increased number of homework assignments turned in causes how well an individual does in class. It is how well an individual does in class causes the number of homework assignments turned in. This is either going to be doubtful or unclear. Okay, the data set, and here's the data set, gives the times of real life Dr. Spears' drive to NGC in minutes during this last semester. Is the average mean of the times a good description of Dr. Spears' drive time? If not, what would be a better indicator? Explain. Okay, so looking at this data, one key feature that we need to deal with is this right here. That 180 is definitely a different thing. And as I discussed with my kids, I was like, hey, what day was that? That was that ice day. That definitely happened. So the mean would not be a good way to say, well, what's the time of my drive? So another way of this set of data would be the median. Since most of the numbers are close in value except for 180, if you put them in order, that middle number would be able to give a better indicator. If I had multiple data points out there, a mode would also be a better choice than mean because, again, you're looking what's occurring the most. Okay, so the table below gives the average number of vehicles sold in a given month, where January equals 1, February equals 2, etc. Draw a scatter plot of the data and approximate the best fitting line for the data. So, as you see here, I put my months down here because they were in my X, so they're on the bottom, and the vehicles sold over here because they're in my Y, and I just started matching up the points. So at 1 month, it was at 80 vehicles sold, so that's why that dot gets there. Then I used my calculator, put in this data. This was my L1. This was my L2. Did my lovely stat calc number 4 and ended up with this information for my line of best fit. And when I graphed it, you saw that that was true. All right, why is the median of a data set not always in the exact middle of a box and whisker plot? Well, if the data distribution is skewed to the left or right, the median value may be represented in an interval on either end. What data can you extract from a box and whisker plot? Those are those 5 data points. If given a box and whisker, you can pull out the minimum, Q1, median, Q3, and maximum. What data can you extract from a dot plot? All the points. You can tell me what every piece of data when you're given a dot plot is. And then what data can you extract from a histogram? Only the amount or the number of values in an interval set. You cannot give me the data points. You cannot give me anything specific. Describe the ways you can use the various plots to interpret and compare data sets. Okay, so dot plots, this gives you exact numbers as well as how many times a specific number appears. So this one gives you a lot of detail. Box and whisker plots, you get your 5 data points, as we discussed before, and it provides you with a good visual of the spread of the data. Histogram only tells you the number in an interval, provides you with a good visual of the spread of the data, though, so if you're just looking for a good spread. Scatter plots, this gives you exact points and gives you a visual of the correlation. All right, number 8 said, the table below shows the number of students who have a part-time job and the hours they work in a given week. Then they ask you to draw a scatter plot of the data and describe the correlation shown. So, again, I knew that this value up here was my x and this value was my y. So I have that labeled, as you can see there, and I just put the dots on the paper there. And then it said, and I mean, as I'm looking at this, I can tell that if I'm going to describe this, I'm going to describe this and say it's negative, right? Because I'm going to say it's definitely a negative correlation. And so then what we did down here in B, it said use your graphing calculator to determine the correlation coefficient of the data. Interpret what the correlation coefficient means to the data. So again, I have this data into my calculator. There's my L1, there's my L2, and I hit my stat calc number 4, and I find out that my R value is the negative 0.88, etc. So this means it has a strong negative correlation. Number 9, if the mean decreases after a single data point is added to a set of data, what can you tell about this data point? Well, that means if it decreases, if the average decreases, the new data point was smaller than the average because it brought down the average. All right, number 10, write out what you do to calculate an outlier. So basically, I brought it down to the kind of last couple steps. Find your IQR, which is your interquartile range. Multiply your IQR by 1.5. Add that amount to Q3, and that will tell you your upper limit of your outlier. What is that and higher? Subtract that amount that you found from your Q1, and that's going to tell you your lower limit. So any amount right here, any number that is equal or above is an outlier. And right here, any number that is equal or below is an outlier. Okay, what are the 3 types of distributions? Normal, symmetric, or none, however you want to say it. Skewed right and skewed left. All right, number 12 gave us a table, displayed the 10 scores, sorry for the typo there, different quizzes out of 10 total points of 2 different classes. Make 2 dot plots and determine the types of distribution, then explain what the distribution means for the data set. So I made one with the blue team scores right here. As you see, made all my dots representing that because, again, they got a 1 out of 10, a 2 out of 10, a 3 out of 10, etc. I made one with my red. That's over here. So this one you can really see. This one is a pretty good example of left skewed because, again, it's going up here at the end, so it has that tail there. Thus, more people scored higher scores. This one I said kind of left skewed because it kind of is, but I was like, this team was all over the scores, not as easy to determine distribution. Number 13 said construct 2 box plots, and I said AKA box and whisker plots, when you make sure that you know those are the same. One for each data set. Compare the medians and measures of variation for each distribution. So I took the data, and as you can see, 2015 is in orange, and 2016 was in green. What was interesting about 2015 was the Q1 and the median were exactly the same at 40. So that made the box and whisker plot look a little bit different than what's normal. Okay, so what we found out was the medians are 40 and 43. Median for this year was 40, 43 for this year. Okay, so they're a little different. The endpoints are more drastic in 2016, so the range is bigger. And in 2015, the Q1 and median are exactly the same. And then the IQR is also larger in 2015 than in 2016. All right, number 14. Below are the calories burned during a workout from a group of people in a gym. So there they are. What is the range of the data? The range of the data is the biggest minus the smallest, so 756. What interval width should you use if you want 4 rows in your table? That means you're going to divide your range by that 4, which in this case equals 189. Then complete the frequency table in the space provided. So I knew I had to have 189 in each of them. So this is what I got for that when I did that math. Okay, again, we're starting with my lowest. Then I did my tallies to figure out how many numbers were in this range, etc. I went ahead and just added them up on the side there for my own benefit, making sure they added up to the amount of numbers there. And then I made a histogram down here. And I just went ahead and used 4 boxes for my bar width just for ease. So there's my intervals, and I ended up writing them that way, which is fine. And I added some color. All right, causation versus correlation. So A says the owner of a movie theater is studying rain and the number of movie tickets sold. Okay, so he's doing his math. Well, this has a positive correlation because it said after analyzing the data, the owner determined that seasons that have more rain tend to have more visitors. More rain equals more visitors equals a positive correlation. However, we cannot determine causation because we don't know for a fact that more rain means more people coming to the movies. B, an advertising firm is collecting data on the amount of likes they get on Facebook compared to the amount of product they sell. They collected their data for the past year and discovered that more likes on Facebook, the more product they sold. So more likes, more product sold, thus a positive correlation. But we cannot technically determine if that is what is making their product sell more, okay? And then this last one, and yes, some students tease me for the dissertation here. In the field of economics, supply and demand is a topic that is often discussed. People understand this concept and make more money on a given item if that item is desired. The Hatchimal is a great example of this concept. Many businesses only had a small amount of these in stock this past December, so businesses were selling them on Amazon for more money than was charged in the stores. Almost every year in December, there is a popular toy item that falls in this supply and demand category. And people always benefit by selling the same items for more money because other people are always willing to pay more for rare items. Other previous examples are the first Nintendo Wii, Tickle Me Elmo, and Cabbage Patch Kids. So, here's the deal. This is an example of a negative correlation because here you have the less items you have, the more money it gets sold for. So that's a negative correlation. And I put here, I was like, really, according to supply and demand theory in economics, this is causation because a smaller amount of supply does ends up demanding a higher price. Okay, so now you have a table with winning scores of 2 basketball teams, and they ask you to find the mean, median, range, interquartile range, and standard deviation, which really we're talking about the population standard deviation for each basketball team in the data set. So plug in the data into your calculator, hit stat calc 1, and I found this mean here. Okay, so I'm doing my math, found all that wonderful stuff. Then it asked me to interpret each result. What can you conclude about the scores of the different basketball teams? Well, I know that the winning score of the Knights is generally higher than the Stars. You see that right here, okay? And then I also know the winning scores of the Stars are more tightly clustered than the Knights, and that is by looking at the range. This has a smaller range than this, so that means the data is tighter clustered. So is this. The interquartile range is much smaller, meaning the data is closer together.